Maybe general things that are still freaking you out? You know, like in general, this class freaks me out, Jeff, so do something with that. Bless you. Bless you. That's bad. Anything from anyone? No? Okay.
What's the next exam?
Say again?
What's the next exam?
The next exam. Oh, yeah, what is the next exam?
We don't have exams, we have tests.
Say what?
Next week on Wednesday.
Next Wednesday, right? Which is what date? Huh? No, it's next. It's the 20th, yeah. It's 4/20. Yes, so that's,
Oh, so you did that on purpose?
no. It just happened. It could happen. Do what you want to.
So what's the next exam again?
Chapter 4 and the last couple things in 3.
So 3 and 11 and a half.
Yes. And there will be one related rates problem, so. Because they gave you way too easy of a problem the last time. Okay, so a couple things to finish up. What if, so somebody help me out, remind me, what does this mean for a function? If it's this, let's say in the interval a to b. What does that mean? Concave down, I love it.
The second derivative is greater than 0.
So it's going to look something like, it's going to have some concavity. Let's say there's a critical number. Let's say that f prime has a critical number at c, which is in a to b. So somewhere in there, right? And this is concave down. So therefore, what must be true at c? This is terrible, but it has to be the location of a local max, of course. I mean, so if I have a critical number in an interval where it's concave down, that's a freaking max there. Does that make sense? So if it's going like this and there's a critical number in there, then that's got to be a maximum. What if it was concave up and there's a critical number in there? It's got to be a freaking minimum. So this is what's called, this is called the second derivative test. So just to remind you guys, the first derivative test was where we found critical numbers and we put them down here and we did the pluses and the minuses and the blah, 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 right? Right. And you can see where it's going up and down, blah, blah, blah. The second derivative test, we don't do this. We just find the second derivative and then plug shit in. So let's do an example. Just to solidify what this means. Oh, let's see. Let me give you a good example. Let's see, where did they introduce this? I forget. Oh. Yeah, okay, let's try this. Let's take a second to figure out what are the critical numbers for f prime. So what's f prime?
4x to the third minus 12x to the second.
I like it. So what do I do to find the critical numbers? Yeah, you think it's 0?
Take out a 4x.
Yeah, take out a 4x squared. You get x minus 3, right? Because you took out 2 x's. So my critical numbers are 0 and 3. Now this is where we would normally do the number line and blah, blah, blah. But look at the second derivative. Is the second derivative difficult?
No.
What is the second derivative?
12x squared minus 24x.
Yeah, 12x squared minus 24x. Now watch this. Let's plug 0 in. So this is what I could do in place of the sign diagram. In place of this, I could just do the second derivative test. Now let's see what, let's do, this is gonna be I like this example. All right, what is f double prime of 0? 0, oh shit, we'll talk about that in a minute. What is f double prime of 3? Oh wait, minus, don't tell me that's also, no it's not, okay. That would have sucked.
36.
108 minus 72, 36, yeah. What's important, now, don't worry about this yet. What's important about this came out how, which tells me what? What's the important thing to notice about the number 36? It is positive. So this looks like what through around 3? What's it look like around 3? Cup up.
Oh.
So what is located at 3? A minimum.
I just thought the positive and the max.
Does that make? That's an alternate thing besides the first derivative test. I could just use the second derivative, especially if it's easy. Now, why do we then learn about the first derivative test? Well, what does this tell me? Is it positive or negative? No. So do I know the concavity there? No. It's, somehow it doesn't have any curvature. So this means the second derivative test fails at 0. I can't determine anything. So then what would I have to go back and do anyway? First derivative test. Oh, let's do that. So that's, I really, secondary test kicks ass when the secondary is kind of easy to figure out. But even then, it might fail, which is why we first do the first derivative test, because that always works, right? So here we can tell it's got a minimum at, how do I figure out what point that is?
Like it reads something.
Yeah, 3 here. Let's see. 3 cubes minus 4 3 cubes is negative 3, so negative 27. Yeah. You want to see what I did? That's good.
Yeah, yeah, thanks.
Huh?
But yeah, I was just confirming.
Thank you, thank you. Now, and then this guy, this is kind of a nice example to show you. Secondary test is kind of nice, especially when the secondary is nice, but it can still fail, which means I'd have to go here and do the sign diagram, at least for 0 now, right? So I could go back up here. I could just kind of focus on 0, I don't care about that. So if I put in like a 2, I get negative, right? And if I put in a negative 2, I still get negative. And there you go, that's why the concavity was 0. It's actually not a max or a min. Maybe. Now be careful. Just because it's 0 for the secondary doesn't mean it's neither. It could still be one of them. In this case, it just came out to be neither a max or a min. Is that cool? Because it's down, it's going down, and then it's like, and then it goes down. So that's secondary test. Too beautiful to believe. If it freaking looks like this and there's a critical number, it must be a minimum. That's just so nice. If it looks like that, it must be a maximum there. And of course, it's again. Okay. Done. Now let's come back to, I did a real brief thing at the end of the last class, and I was trying to do 2 things at once, which threw me off. The asymptotes, just to remind you of those, and then L'Hopital's is a little bit different. So what L'Hopital's is trying to do, all right, if I have and this becomes this, right? Okay. What does that mean? What is f of 0? And what is g of 0? What's he got to do? 0 and 0, right? They're both 0, okay. I like it, I like it. Stay with me, stay with me. Now watch this. Isn't f of x doing what we did on the quiz today? Isn't that approximately f of 0 plus f prime of 0 times x minus a, right? g of x approximately j of 0 plus g prime of 0 times x minus 0. Now, I just erased the important thing. This is 0, yes? And this is 0, we just said. So doesn't this, as x gets closer to 0, somebody tell me, when are these approximations better and better? What did I build them both around? 0. So when are they the best? When x equals 0. And when are they pretty damn good? When x is really close to 0. And isn't that exactly what this stupid thing says it wants to do?
Yeah.
So can't I say this is really all, this is, in fact, as I get closer to 0, this is strictly equal to, I can replace this with this. And I can replace this with this. I really want that to make sense, because the more I zoom into it at 0, the flatter it gets, right? I zoom in and the curve bends out, it's local linearity. So really close to 0, they're both just frickin' straight lines. Well, what happens to these? Cancel out. Let me screw it, Jess, all right. And can you guys see that this is, where'd that 0 come from in here? The fact that we're going to 0, right? So can't I just generally make it this? Because then it would throw a 0 in. So look what this says now. The limit of the ratio of two functions where it's indeterminate form 0 over 0, right? How can I analyze that limit? I can just take the derivatives of the top and bottom and then figure out that limit instead. Now, on one level, this might feel like, what the shit? Why would you do that? Derivatives can get gross. But let me just recapture what we just did there. Because there's a lot of proof, there's a lot of other shit. So, given f and g, where the limit of the ratio is in the form 0 over 0, we can do this. We can apply L'Hopital's. So the limit of the ratio of two functions, in this case, is equal to the limit of the ratio of their derivatives. And if you think about it, it's all about who's getting to something faster, who's going faster. That's kind of like what this kind of captures. Going faster is derivatives. So on a more just conceptual level, this kind of makes sense that it would have to do with how quickly f and g are moving. How quickly are they getting there, right? Let's do a concrete example. Do you have one, Jeff? Maybe. Oh, by the way, real quick, before we do a concrete example, what if I had a situation where this was in this form? Is that indeterminate? Yes, okay. But is it the way it needed to be for all this to work? No, I needed zeros there, didn't I? So here's what I could do. I could just frickin' do this. Just stay with me, stay with me. I want to show you that everything we just did will still work, even if the limit is in that form. Are you guys cool with the fact that these are exactly the same? This is the same as this, yes? 1 over f of x, wouldn't that pop up? And isn't g of x on the bottom? I mean, so those are the same stupid things. But now, what is this doing? What form is this in now? If f went to infinity, 1 over f is going to... If f goes to infinity, 1 over f is going to 0. I really want you guys with me. So it definitely works if it starts off as the ratio 0 over 0. But if it's infinity over infinity, I could just do that. And then I could call, let me see if you guys, again, this is the proof. You're not actually going to do this in your work. But in the proof, I could call 1 over g, I could just call it h. And 1 over f, I can call it k. And then I can just do the same shit, right? Isn't this 0 over 0 now? If h is this, k is this is 0 over 0, I can take the derivatives. Okay. Now in practice, we don't actually have to do that because all the flipping would unflip and who gives a shit. But this is just showing you that L'Hopital's will still work if it's this or if it's this. Now what if it isn't indeterminate? L'Hopital's then won't work because it's built on this shit. So if you have something that's not indeterminate and you do derivatives, the answer could be completely different from what it's supposed to be. You have no idea. L'Hopital's like, I don't know what the shit you're doing because I only work for these situations. Okay. Maybe. Now let's do a concrete example because this is abstract freakiness. Oh, let's see what you got, Jeff. Yeah, let's do, I like it. What form is that in?
0, 0.
Yeah, natural log of 1 would go to 0, and 1 minus 1 would go to 0. So does L'Hopital's work here? So this is what you should do, not just for yourself, but for me too, right? You should say, put this whenever you apply it, so that you remember what the shit happened and I can see what the shit's happened, right? So if I apply L'Hopital's, what do I do? I know I'm allowed to.
Take the derivative.
Yeah, what's the derivative of natural log of x?
1 over x.
And what's the derivative of x minus 1?
1.
Frickin' 1, right? Now is that still indeterminate? What's the limit as x goes to 1 of this? 1. Would I be allowed to do L'Hopital's here another time? Not only would you not be allowed to, why the shit would you want to? If it's not indeterminate, that means it's determinate. I love that word. And what does that mean? You could determine the answer. Just freaking do it. Why do extra shit? Not only should you not, but if you do, it could come out wrong. In fact, real quick, let me rewrite this. Well, this will actually, well, okay, well, look what happens. If I try to apply L'Hopital's, what's the derivative of the top? 0. What's the derivative of the bottom? Is that the right answer? No, shit. Yep. And L'Hopital says, it's not my fault, dude. Try to use me at the wrong freaking time, right? I really want that. So this is what some of the tutors were showing you before you knew what the shit that was. Okay, and now you kind of hopefully understand why this works. Here, you guys try one. Let's do, oh, okay. Well, let's do this. Not that one, that's too weird. I'll do that one with you in a minute. Yeah. Well, okay, here. Yeah. It's not too bad, right? happened in this one. Right? Nothing interesting happened here. Get some on that. Is this in the right form?
Yeah.
Yeah, this is in the form 0 over, what's in 0 is 1 minus 1 is 0. So I can apply L'Hopital's. Derivative at the top, I'll do, ah! Fine, that's easy. What's the derivative at the bottom? Negative, good. Negative sine x. What do you guys think? This one's interesting. Is that still indeterminate? Obviously not, because there's a 1 on top, right? What happens to the bottom? Goes to
Zero.
0, right? So this is a bit of a thinker. What does sine x look like? How does it go through 0? What is it? It's got the cup up down here and then cup down here, right? That's sine. So and of course negative sign would just be this. What matters is if I approach 0 from this side, aren't all the things negative? So that would be negative infinity then, right? 1 over 0, but all the inputs are negative. Yes? If I come in from this side, that's positive. They're all positive. As I approach 0 from this side, aren't all the values positive? So it's like 1 over 0.01, 1 over 0.001, 1 over 0.0001. So it's going in positive infinity from that side, negative infinity from that side. So what's the limit? Do the limits match from both sides? Do the limits match? No, careful. This is a picture of sine. Yes? Negative sign. So don't look at this. I mean, this, I really want you to understand. It looks like 1 over 0, which you would be tempted to write this, but you would be wrong. Because what does limit as x go to 0 mean? Doesn't it mean from both directions? Well, as I come from below, I'm putting positive shit in here. So that would be positive infinity. And as I come from above, I'm putting negative shit in there. So that would be negative infinity. What are we saying when the limits don't match?
Does not exist.
Does not exist. Yeah. So don't forget, just because it becomes determinate doesn't mean it's a gimme, right? And I understand if you put an infinity there, I would understand, but it would be wrong. That would understand. What happened to this dude? Well, first off, what form is he in?
Infinity over
Infinity over infinity, right? So does L'Hopital's work?
No, but yes.
Yes. So we built it around 0 over 0, and they said, oh yeah, it would work for infinity over infinity because there's some weird shit you could do to make it still work. So it will directly work on 0 over 0 or infinity over infinity, right? So if I apply it, what's the derivative of this?
It's
One
x
half
over
to the x.
It's e to the x over 2 times the derivative of the inside, which is 1/2, right? Okay. Over, I don't know guys, what's the derivative of x squared?
Oh boy.
Like it. What form is that in? Is that determinate yet? This is still freaking infinity, right? And this is still freaking infinity. By the way, see how the numbers, what number is this really? 1/2 divided by 2?
Wait.
1/4, right? So don't worry about I'll just bring the 1/4 out. Just get it out of the way. And now I can apply L'Hopital's. I can do it again, of course. I can keep doing it. Did I put a little elevation? No, I can keep applying L'Hopital's until it's not indeterminate. Because when does L'Hopital's work? When it's indeterminate. If it was still indeterminate, I could do it again. It's crazy. So I get 1/4 limit. Derivative of this we already did. What's the derivative of 2x? 2. So now this limit is very easy to see, yes? What's this limit? As x goes to infinity, it's infinity. The bottom ain't doing shit to me anymore. It can't keep up. It just stays at 2. So this is infinity, positive infinity. E to the infinity is definitely just infinity. Okay, maybe. So real quick, you guys remember, this is kind of dumb. This is not a place I would use L'Hopital's, but just to show you, it'll still work. Do you guys remember what the idea was with something like this?
Gotta kill it.
Gotta kill him. Gotta kill him?
Yeah, gotta.
What's the shortcut? Can anyone tell me that answer is bam? Just tell me.
1/3.
1/3, I love it, thank you. Right? Just the ratio of the coefficients of the highest degree term, right? But what form is it in? What form is this in? As x goes to infinity.
Infinity over infinity.
Right? So this would be, so I can apply L'Hopital's. So I'll do it real quick. 4x minus 4 over another square. 12x, and that's gone, right? Is it still indeterminate? Yes.
Yes.
Right? So then I can apply it again. 4, that's gone, over 12, 1/3, which we already knew. So again, what did I just say? I wouldn't do this shit because I know the shortcut, but it is nice to see this new L'Hopital's. It better agree with what we knew the answer was supposed to be, or else something's wrong. And it does. Okay, good. Okay. So be very careful. You know the very first thing you do with any limit is you plug the number in to see if there's any extra work to do, or can you just see what the answer is? We know that already. So if I plug the number in, it's not indeterminate, why would I do anything else? Because I can determine the answer. But now we have an extra tool. If it is indeterminate, there's other shit we can do. There's L'Hopital's now, right? Maybe. Yes.
That's a 12, right? Underneath the 4x.
That's trying to be a 12, yeah. By 2, let's put that in. Right, because it would be 12. Bang, bang, bang. Okay, so that's L'Hopital's. Shoot. Now, I know, nobody said this to me, but I know you guys are all upset because it's been a while since we had calculus word problems. So,
Yeah, it's never not funny, Jeff.
Optimization problem. You did these in pre-calculus, but you did them, like, does anyone remember how to find, if my profit function is this, sure. Can somebody tell me how to find the maximum profit? If that's my profit function, what's special about that function? What kind of function is it?
Oh, no.
More specific.
Parabola.
It's parabolic, it's quadratic, right? So do I need calculus to know where the, why would there be a maximum profit? What kind of parabola is this? It opens down, which we now know is called concave down, right? But it just opens down. So this is the kind of problem you guys did in pre-calculus, and it was optimization problems. It was finding the max or min something. But you could only handle parabolas. Let's see if you remember. What was the shortcut? I actually proved it with calculus before. Anybody remember the shortcut to find the vertex, the x piece?
B divided by 2a.
Yeah, negative b over 2a. So negative 80 over twice negative 0.2, which will be 800 divided by 4, which is 200. I just multiply top and bottom by 10, make it nice. And then I could just plug 200 in and see what my max profit is. Hopefully it's positive, that would be nice, right? You guys, I don't know if you remember that at all. Well, you've done optimization problems before, but you could only use parabolas because that's the only thing we knew how to find the max. Do we have more ways to find mins and maxes now?
Of course we do. So guess what? You're gonna get all kinds of funky ass shit. Because we can, no matter what the shit it looks like, we can do it. We can find the max and min, we got derivatives, we got all this stuff. Okay. I'm sure you're so excited about it. Yay! So what kind of problems are we gonna see? We're gonna see, okay, let me start with the simplest kind of problem. Sure, okay, sure. So find two numbers whose product is 100 and whose sum is minimum. So the two numbers that multiply to be 100, whose sum to the smallest thing. So like 2 and 50 multiply to be 100, but they sum to be 52, yes? 5 and 20 multiply to be 100, and they only add to be 25. So somewhere there's a sweet spot. Some of you guys might know already what it is, but hold on to it. This, hopefully, I love you guys so much. Stay with me. Is this word problem look really difficult? Does it? No. Can you write equations for what they tell me and what they ask me? What do they just tell me? What part of this is them just telling me shit? Just,
It's 100.
say again?
I was gonna say sum is minimal.
That's the question, yes? Isn't this what they're telling me? Didn't they just tell me the product is 100? So what are your two numbers? This is where the part that people hate about word problems, you gotta set up what the variables are, and then you gotta set up the equations. Once you got those, you can just attack them, right? Give me your variables. Holy shit. So how do I write what they tell me? Careful.
X times Y.
Good. And what is it they're asking me? X plus y, let's call that the sum. Give it a name, it's the sum formula, is that cool? Do you remember that we talked about tell me, ask me before? Okay. If you take what they give you and you break it down like this, you can focus on one thing at a time, which is a huge mistake people make with word problems, is they kind of keep the whole thing in their head and then you go a little insane. Like, holy shit, I can't do that either. I have to break it into parts. Now, we need to minimize this, but there's too many variables. So what can I do here to help me with this? Do you guys remember? Yes. So which one do you want to solve for? I don't care. X? Okay. So you get x equals, how do you kill the y? Divide. So I know this. This is true. Period. That's true, right? Which is how I got 50 and 2 and 20 and 5, right? Blue, you're dying. So how do I rewrite this now? And now how do I find the minimum? I've created our function, now you're back in section 4.1. So 4.7 really is, we're not going to give you the function, you have to do steps and create your function, and then how do I find the minimum now? What do I do? Take the derivative. I'll do this part. By the way, you're doing, right? Because you pick your own variables, so you're just going to do it with respect to whatever you got there. And what's the derivative of 100 over y? So 100y to the negative 1. So I can write this as 100y to the negative 1, right? So what is that derivative? Negative 100 times y to the negative 2. And then, right, the minute we got here, we're back in freaking section 4.1. Some of you guys are like, that's still a problem for me, but do it, give it to me. Where do I go from here? We got the derivative, set it equal to 0, right? I'm going to multiply by y squared right away. I'm going to
arrange this. I multiply by y squared because I hate my variable on the bottom, right? Then you can factor this, and what do you get? Y equals 10 or negative 10? So if y is 10, what's x?
About 2.
So if y is 10, x is 10. And if y is negative 10, x is negative 10. Yes? So where's the sum minimal? Yeah. Now, if I would have said, and where the numbers are positive, it would have been this one. Right? So here's the idea. I don't know if you guys know this. If I have a rectangle and I have a certain amount of material to use for the sides, what shape makes the area the biggest is always a square. Isn't that what we just got? So if I use only positive sides, isn't this the area of the rectangle? So what's the smallest amount of material I need to get this area? It would make a square. That should kind of make some sense. Because I can make a rectangle look like this shit, right? To make the area 100, I'm probably gonna need more fencing, yes? I mean, that's not gonna, it doesn't minimize the amount of fence I need to use. Okay, maybe. So this section really, the hard part is going to be getting to here, and then you just attack it like we know to do from section 4. Let me go ahead and give you this. I think we'll look at, let's see what happens. Give you this. So real quick, you have a rectangular area with an area of 180 square feet. Right? So just draw a rectangle. And again, you get to pick your variables. But we can use x and y. I mean, you can use L and W, whatever you feel like. Right? So let's make this x and this y. Can you set up the area equation? Yeah, so area is xy, and we know the area is 180 square feet, right? So this is what they tell me. Now, this one I take a little bit of a curveball here. So read through part B. There's one major thing that hopefully sticks out to you, because I think in the homework they did this in at least one place. Does anyone see something majorly bad just right on the surface of what I'm telling you? Okay, so that's not bad. I mean, that's just part of the problem. I didn't make all it. For some reason, one side is more important, right? They have to use a better quality fence for some reason. So that's part of the problem, but what's kind of wrong in the way they gave me my information? Does anyone see something? What was the area again? 180 what?
Square.
Square feet? What are your costs?
Oh, yeah, it's different.
Oh, shit, right? Which is really dumb. But I think they did this, I did this on purpose because I think in one problem they did. I want everything in terms of feet or yards. Which one? Feet, because my area is in square feet, yes? So let's change the $45 per yard. What would that be per foot? It's not that hard. How many feet in a yard? 3. So 45 per 1 yard is 45 per 3 feet. Careful, not times, right? Again, 45 per 1 yard is 45 per 3 feet. which is how much per foot? 15. Okay, cool. Let's kind of complete our picture here, right? So it's up to you. Does it matter which side is the more expensive side? Does it matter which one? Does it say? Doesn't matter. We're shit. Right? If somebody else picked a different one, you guys will actually end up with the same answers. You have to. So, I mean, somebody help me out. Left, right, top, bottom. Which one's the expensive one?
Top.
Sure. I heard top first. So what's the cost of this side? 15x. Right? Because it's x feet, 15 per foot. So what's the cost of these two sides? 10y. 10y. What's the cost of this side? 10x. So what is your, let's set them on. Yeah. What is your total cost? Yeah. 25x plus 20y. You guys see that? If the problem says minimize the cost, what function do you have to create? The frickin' cost function, right? You don't write the perimeter and start doing shit, because is the perimeter related directly to the cost? No. I really want to make sense. If they say minimize shoe width, your equation better be a shoe width equation, yes? If they say maximize the life of a dog, your equation better be frickin' dog lifespan in years or whatever, yes? That's what the equation better be built to give you, yes? Does that make sense? So what I get when this kind of problem is somebody writes the perimeter as 2x plus 2y and they start doing derivatives. I'm like, I don't care about the perimeter, I want the cost. I want to minimize the cost, right? So your function better be a cost function. Now, what's wrong? Too many damn variables. What can I do? Solve for one of the variables, doesn't matter which one. So you can plug it in, so you have a function of x or a function of y. And then we do derivatives, and then we're back in section 4.1.
Did you implicit or
No, because it's not, well, you'd have to do, you could do implicit and then you bring shit in which case you're doing exactly what we're doing, just in the opposite order, and it makes it more difficult in the middle than it has to be. Yeah. I think I'll stop there. We'll pick back up on this problem next time, but we're basically at the part where you throw that in, you're back in section 4.1. Okay. So on Wednesday I'll have the quizzes graded. Yeah. And then Friday I'll have a practice test for you guys.